All right, so hopefully you've had a chance to take a look at the warm-up and think about what cross-sections of a cone might look like. Today, we're going to explore what these cross-sections look like. It's the beginning of our what we call conics unit, which conics are formed by cross-sections of what we call a double cone where they are joined at the apex. So hopefully you've had a chance to play around a little bit with the interactive applet on the on your screen. So we're going to talk about how we get each of the different conics. So this is just kind of a general overview today of the different conics that we get. So the first thing we're going to explore is what happens as we make horizontal cuts further from the apex. So basically, I'm going to go ahead and make my plane so that it is horizontal. So I'm going to set it at 0 degrees here. And as you can see, if it's at the apex, I just kind of get a point. So it's really just this one point where they intersect right here. So I can just get a single point if I have a horizontal cross-section, or as I move away from the apex, notice how I get circles that are formed around those cones. Okay, so that's one type of conic. One type of conic is actually a circle. So as you can see here, if you wanted to play with this on your own a little bit after the video, notice how when my plane is set at 0 degrees or a horizontal cross-section, I get a circle. That's the type of what we call conic that we get. All right, so now what happens if we change the slope? Actually, let's go ahead and, sorry about that. We're gonna set the slope to 0 and the height to 0. And this is just basically, and I forgot that I had to clear this. So if I set the height to 0, I already kind of said this, but when your height is at 0 and your slope is at 0 degrees, notice that it's just the single point. And then as I move away from the apex, I actually get a what we call a circle. And for some reason, this is being very strange. We just get a circle. There you go. Okay. All right. So what happens if we change the slope of the intersecting plane? So what's going to happen if we do something like this? And notice that I get what is called a parabola. When I get to a certain point, it then becomes a hyperbola. And I can take and slide this as well, kind of up and down. And depending on what that angle is of the plane that it intersects, it's either going to be what we call a parabola. And a parabola is formed basically when the slope of the plane is the same as the slope of the slant. So whenever this plane, see this slant right here? So when the slant is the same as the plane, that is when I just get a parabola. So right now it says ellipse because it's not the same as, I get it to 1 point, there you go. So it's like right at about 45 degrees. That means the slant of that cone is at 45 degrees. And now also my plane is set at 45 degrees. So therefore I get what's called a parabola. So parabolas you studied last year, they have the equation y equals x squared. And so that is actually, believe it or not, it is actually a conic. The other thing that we have is how can I make my parabola more narrow? So the way I make it more narrow is to basically slide it left and right. I can make it more narrow as I get to the other side, and then it can flip down to the other cone as well. But all of these are going to be considered parabolas because, again, the slant of my plane is the same as the slant of the cone. So whenever the slant of the plane is the same as the slant of the cone, again, this is the slant of my cone right here. Whenever that is at the same as the slant of my plane, then I get a parabola. Okay. Also, I can now change the slope to a 90-degree angle. So we've talked about circles, we've talked about parabolas. Now, if I go ahead and change it so that it's at 90 degrees, notice now I get what is called a hyperbola. So a hyperbola is basically where the plane intersects both cones, and I kind of get these mirroring parabolas. So a hyperbola is basically when I get that mirroring effect in the double cone, and I kind of get like, it looks kind of like a double parabola. but I call that a hyperbola, okay? And then I also get what happens when the vertical cuts are farther from the apex. So as I pull them away from the apex, the parabolas, or kind of those branches of the parabolas, which I would call the entire conic a hyperbola, become more wide as it approaches the outside of the cone. And then the last one that we haven't really talked too much about is what we call an ellipse. And an ellipse is a shape, and I will kind of show you here that an ellipse is basically when it goes through only one of the cones on one side. So again, it's when my slant, here you go, see, you can kind of get that ellipse looking figure. So an ellipse is when your slant just goes through one of the cones, okay? And you get this circular, kind of oval looking figure, all right? So we're gonna now go ahead and define these. We're gonna go ahead and go to page 2. I'd like you to go ahead and record these notes on page 2. So a circle is basically formed by when the cross section is parallel to the base of the cones. It is a closed figure, meaning that it doesn't have any kind of like ways that the inside points can interfere with the outside points. So the closed figure means that it just has a beginning and end that are connected. And so all points in the circle are equidistant from the center, which we've talked a lot about circles already this year. An ellipse is a cross section is angled so that it cuts through both slants of one cone. It is again a closed figure, but it is more of an oval shape. So it kind of looks like this. We also have a parabola, and again, you can pause these as you go along to get the notes down. Parabola is a cross section is parallel to the slant of the cone. We talked about that idea of the slant and the cross section being at the same degree, so that it's not going through the apex. And again, a parabola is an open figure, meaning that it starts and ends, well, it doesn't really have a beginning and end per se, that it's open, meaning that both ends of the parabola extend in either direction. Finally, we have the hyperbolas. That's the cross section is perpendicular to the bases or angled so that it cuts through both cones. And remember, we have hyperbolas kind of have this mirroring effect of the parabolas. Not exactly like that, but kind of you kind of get the gist here. It is an open figure because I have kind of a no beginning and end. I have arrows on either side. So please make sure you get these written into your notes on page 2. You can pause this video if you need to. We also, so this is kind of a visual way of looking at conic sections as well. So we have the diagonal slice, which makes the ellipse. We have a horizontal slice that makes a circle. We have a vertical slice that slices through both cones would be a hyperbola. And then of course a parabola, which is just a diagonal slope, a diagonal cut. And the slant is going to be the same as the slant of the cone itself. Okay? All right, so that's it for today. You're going to go ahead and complete pages 3 through 7 in your packet. Once you're finished that, you're going to go ahead and work on your progress check review. I'll see you guys tomorrow.